a fully fledged three-turreted land cruiser that Soviet engineers recreated from memory after a failed espionage deal in London. This 30-ton vehicle managed to speed across off-road terrain at the rate of a light-wheeled tank, presenting a formidable presence to any potential opponent. Today we look at the T-28, the first Soviet multi-turreted medium tank and a major steel symbol of the Soviet Union's pre-war power. How did the Soviet delegation manage to copy the secret British Vickers project in detail while refusing to pay exorbitant amounts of money to the British? Why did a medium tank need 3 turrets and a 6-man crew? And what critical mistake did the country's leadership make by launching this complex tank into mass production before the completion of field trials? The fate of the T-28 interwove the major achievements of Soviet industry and the tragedy of the first months of 1941. Watch this video to the end to learn why this multi-turreted vehicle paved the way for the KV-1 and T-34 and how it actually performed in combat. Let's begin. The late 1920s. Europe had not yet recovered from the First World War, the most destructive conflict in human history at that point. Millions of soldiers spent 4 years in muddy trenches while shells whistled overhead. This war changed everything. It reshaped maps, borders, and governments. Most importantly, it transformed how military minds conceptualized warfare. It was there, in those muddy trenches, that the idea was born which eventually led to the development of this vehicle. The tank emerged as an answer to one specific question: how to stop dying in the trenches. The first machines were crude, slow, and unreliable, but they worked. They broke through barbed wire entanglements, crushed firing points, and shielded infantry. Military theorists around the world began to ponder, what comes next? What should the next generation tank look like? There were many answers, perhaps too many. During the 1920s and 1930s, every nation took its own path, experimenting with light tanks, heavy tanks, tankettes, and self-propelled guns. It was a period of diverse theories and trials. Some believed speed was paramount, others prioritized armor, and some focused on firepower. In the Soviet Union, this issue was approached systematically. The Directorate of Mechanization and Motorization of the Red Army, the body responsible for the development of armored forces, formulated a clear concept consisting of 3 classes of vehicles for 3 distinct roles. The light tank was to be a fast scout and open terrain support vehicle. The heavy tank was intended for storming permanent fortifications of concrete and steel. The medium tank, however, was a different story. The medium tank had to accomplish what neither light nor heavy tanks could. Its primary mission was to advance alongside infantry through multiple lines of trenches, not just a single row, but an entire defensive system of wire, bunkers, machine gun nests, and artillery, targeting earth and timber fortifications that were resistant to light tank shells, but too minor to justify deploying expensive heavy tanks. And this is where the most interesting part begins. Since that was the task, a single turret was not enough. A gun of at least 45 millimeters was required to suppress firing points, with the ability to fire in all directions. Machine guns were also needed to keep enemy infantry away from the hull and protect friendly infantry. This required multiple firing points and consequently multiple turrets, a multi-turreted medium tank. On paper, it sounded logical and convincing, but how to realize this in metal was something no one in the USSR quite knew. The answer was found neither in Moscow nor in Berlin. It was found in London. In late 1929 and early 1930, a Soviet purchasing commission traveled to Europe. Officially, they sought experience and technology. Unofficially, they looked for ready-made solutions that could be adapted or copied. The delegation was led by Innokenty Kalepsky, head of the Directorate of Mechanization and Motorization of the Red Army, a man with a sharp mind and a clear understanding of what the Soviet armored forces needed. His deputy was Semyon Ginsburg, a young designer who had already established himself as a specialist with an unconventional approach to engineering. One of the destinations was Great Britain. At that point, the British tank industry was among the most advanced in the world, not the largest in terms of volume, but certainly one of the most innovative. It was the British who had first used tanks in battle during the First World War, and they had continued to develop them ever since. The delegation stood before a vehicle designed by Vickers in 1926-1927 under a direct commission from the British military. the medium tank A6. It was commonly referred to as the Vickers 16-tonner, named after the maximum weight limit it was not supposed to exceed. This limit was intentional. 16 tons was the standard capacity of a British Army pontoon bridge. A tank unable to cross such bridges lost much of its utility. Soviet designers looked at the A6 and realized this was it. 3 turrets on 2 levels, with the upper turret housing a gun and the 2 lower ones carrying machine guns. It was a vehicle capable of suppressing firing points with cannon fire while simultaneously keeping infantry at bay with machine gun fire from both sides. This was exactly what they had envisioned back home when developing the medium tank concept. Its mass allowed the A6 to break through brick walls or crush paths through wire entanglements. The hull length was calculated to prevent the tank from falling into standard infantry trenches. This was not a coincidence. It was precise engineering mathematics. The delegation wanted to buy it. And then negotiations began. The British side demanded £20,000 sterling just for the opportunity to examine the vehicle's design. Additionally, they required a mandatory order of 10 tanks at £16,000 each, plus purchase contracts for the Carden-Loyd Mark VI tankette and the Vickers 6-ton light tank. Essentially, the British offered a package deal. If you wanted the medium tank, you had to purchase everything else as well. The USSR assessed the offer and made a decision that ultimately defined the next decade of Soviet tank development. They decided to purchase the tankette and the 6-ton light tank, which later became the Soviet T-27 and T-26. However, they resolved to build the medium tank on their own. The technical insights gained during their inspection of the A6 were already in the delegation's possession. No blueprints had been sold, but the designer's observations and memory served as practical tools. Ginzburg did not bring back a physical tank. He brought back an understanding of its layout and mechanisms, which proved to be sufficient. December 1930. The Directorate of Mechanization and Motorization of the Red Army issued an official design specification for a medium tank. This was not a recommendation or a proposal, but a directive with specific requirements and tight deadlines. 2 teams were assigned to work on the project simultaneously. The first was the Department of Mechanization and Motorization of the Dzerzhinsky Military Technical Academy, consisting of scholars and theorists with an academic approach. The second was the Tank and Tractor Design Bureau of the All-Union Ordnance Association, led by Semyon Ginzburg, who had studied the British A6 in detail just months prior. This was a competition, and each participant held distinct advantages. The academics relied on theory, calculations, and a fundamental engineering school. Ginzburg's team, however, possessed practical experience. Having seen the physical vehicle, they understood its operation in reality. Additionally, they drew on experience from collaboration with German counterparts. At the joint Soviet-German tank school in Kazan, Ginzburg's designers had studied German blueprints of the Grosstraktors, experimental medium tanks developed by Germany under the guise of agricultural tractors to bypass the Treaty of Versailles. These 2 sources of knowledge, British design concepts and German developments, were combined within a single design team. In July 1931, the competition results were finalized, and Ginzburg's team was declared the winner, a result that surprised few, as practical experience outweighed pure theory. Then began the most demanding phase, turning blueprints into metal. During this stage, the factory workers achieved a major production milestone. The first prototype of the new medium tank, designated the T-28, was assembled using mild, non-armored steel, a standard structural metal used to verify layout and mechanical performance rather than for combat. This was common practice, as armor steel was expensive and difficult to machine, making its use on an initial prototype impractical. On May 2, 1932, the vehicle moved under its own power for the first time in the factory yard. It was powered by an M17 gasoline engine, similar to those used in T-26 tanks in the BT-7 fast tank series. Since the newly planned 45mm gun was not yet ready, a 37mm gun was installed from existing stocks instead. It was not perfect, but it was functional. On June 11th of that year, the tank was demonstrated to military officials, initiating the next phase of evaluations. The military inspected and evaluated the vehicle, concluding that while promising, its capabilities needed to be expanded. First, the armament was deemed insufficient. Exercises had shown that 45mm shells were ineffective even against basic earth and timber fortifications, prompting a request for a 76mm gun. Second, they requested a new tank diesel engine designated PGE to replace the gasoline engine. The designers set to work and successfully integrated the 76mm gun. However, the engine upgrade failed. The PGE project was canceled and never entered mass production, meaning the tank proceeded to production with its existing power plant. In late October 1932, the T-28 was officially adopted. Notably, the Soviet Council of Labor and Defense approved mass production before official trials were fully completed, indicating strong confidence in the design. Those key figures involved in developing the tank were awarded the Order of Lenin, the state's highest decoration at the time. Adopting a tank for service and establishing its mass production are entirely different challenges. The former is an administrative decision. The latter involves the daily efforts of thousands of workers, machinery, factories, and supply chains. The Krasny Putilovets plant in Leningrad was chosen to manufacture the T-28. Known as the Putilov factory before the revolution, it had been one of the largest industrial enterprises in the Russian Empire. By the 1930s, it was a massive industrial facility with expansive workshops, skilled workers, and a highly capable manufacturing base. The selection was deliberate. The factory possessed decades of experience manufacturing complex machinery, including artillery, locomotives, turbines, and cranes. Since the autumn of 1931, the plant had also participated in the armored vehicle program, manufacturing components for the T-26 light tank, such as suspension bogies, drive sprockets, final drives, and gearbox parts. Consequently, the workforce was already familiar with the requirements of tank production. However, the T-28 was significantly more complex. During production preparations, designers continued to modify the vehicle. The mass-produced version differed so substantially from the June 1932 prototype that they could be considered distinct designs. Blueprints were revised, components recalculated, and the layouts of several mechanical assemblies rearranged. The most significant change was the primary armament. In place of the prototype's 37mm gun, a 76mm Model 1927/32 tank gun was installed in the main turret. This weapon fired a much larger shell with significantly greater destructive power, capable of destroying rather than merely damaging earth and timber fortifications. The two smaller auxiliary turrets were equipped with 7.62mm machine guns, the standard rifle caliber of the era, to handle close-in defense, suppress enemy infantry, and cover blind spots around the hull. The engine choice is an illustrative aspect of the development process. Upon accepting the vehicle, the military requested the installation of the PGE diesel engine. Diesel engines offered advantages over gasoline units, including lower fuel consumption, reduced fire risk, and a greater operating range, which are critical factors for combat vehicles. However, the PGE engine project failed and never entered production. The designers faced a choice: wait for a new diesel engine and delay the tank indefinitely, or proceed with available technology. They opted for the M17, the same 450 horsepower gasoline engine used in the prototype. This was an aircraft engine adapted for armored vehicles, representing a practical, if compromised, solution. Mass production ramped up gradually. Early vehicles were difficult to manufacture due to tight tolerances and the need to refine production techniques. Output increased annually. By 1938, following extensive revisions and recalculations of components in 1937, production returned to 1936 levels while achieving a substantial improvement in manufacturing quality. Over its production run, the T-28 underwent several modifications, leading to the models of 1933, 1934, 1938, and 1940. Each version introduced improvements, ranging from minor updates to significant alterations in armament, optics, transmission reliability, and maintenance accessibility for problematic components. The final variant, the Model 1940, featured a conical main turret instead of a cylindrical one. Conical shapes offer better ballistic deflection, a basic principle of armor design. However, only 13 such vehicles with conical turrets were built out of nearly 600 total, making them exceptionally rare. Tanks retrofitted with additional applique armor plates to enhance protection were designated T-28E, with E standing for ekranirovani, or armored with screens. Ultimately, this resulted in a vehicle that, in the mid-1930s, was considered one of the most effective medium tanks of its era. Not the fastest or most heavily armored, but highly balanced for its intended role. To understand the significance of the T-28, it is necessary to examine its specific design details, which reveal several notable engineering solutions. We begin with its physical dimensions. The T-28 was a large vehicle, with a hull length of approximately 7.5 meters, a width of nearly 2.8 meters, and a height of just over 2.6 meters. The combat weight of production models was around 28 tons, which is comparable to the empty weight of a standard modern railway carriage, making it a substantial piece of machinery. The hull was divided into three sections: the driver's compartment at the front, the fighting compartment in the center, and the engine transmission compartment at the rear. This layout later became the standard configuration for most tanks globally. The three turrets represented the primary design feature of the vehicle. The main turret was positioned in the center of the hull on an elevated platform. It housed the primary 76mm gun. The turret offered a full 360-degree traverse, allowing the crew to fire in any direction without turning the hull. A coaxial 7.62mm machine gun was mounted alongside the main gun, and another machine gun was installed in the rear turret bustle to cover the rear arc. The two smaller auxiliary turrets were located lower and ahead of the main turret, on the left and right sides of the hull front. Each contained a single machine gun. While their horizontal traverse was limited compared to the main turret, they covered the forward sectors on both sides of the hull. This arrangement allowed the T-28 to engage multiple targets in different directions simultaneously. In total, the armament consisted of one gun and 4 machine guns, providing firepower that exceeded that of most contemporary designs. The crew consisted of 6 members: the driver and a machine gunner radio operator in the forward hull, the commander, gunner, and loader in the main turret, and a second machine gunner who operated the 2 forward auxiliary turrets by moving between them as needed. Regarding armor, it is necessary to contextualize the level of protection. Upon adoption in 1932, the T-28's armor was typical for its era. The hull front measured 30 millimeters, the sides and rear were 20 millimeters, and the turrets ranged from 20 to 30 millimeters. This protection was sufficient to withstand machine gun fire and shell fragments, which were the primary threats anticipated during infantry support missions. However, anti-tank artillery advanced rapidly during the 1930s. The armor thickness that was adequate in 1932 no longer provided sufficient protection against newer anti-tank guns by the end of the decade. This issue affected an entire generation of tanks from that period. They became obsolete not due to poor design, but because defensive and offensive technologies evolved faster than anticipated. The 450 horsepower M17 gasoline engine propelled the 28-ton vehicle to a maximum speed of 37 kilometers per hour on roads. The road range was approximately 180 kilometers, which was sufficient for operational movements within divisional maneuvers. The suspension and running gear deserve mention. It consisted of 6 road wheels per side, grouped in pairs into 3 bogies, with leaf spring suspension. While not the most advanced suspension design of the period, it was robust and easy to maintain, and its reliability was frequently noted by crews operating the vehicles in the field. In the mid-1930s, as global tank development was still defining standards, the T-28 compared favorably with its international contemporaries. The British A6, which had inspired the design, never advanced beyond the prototype stage. German medium tanks of the era carried lighter armament, while French designs generally lacked comparable mobility. The Soviet 3-turreted, 6-man medium tank stood as one of the more balanced combat vehicles of its class during that period. No combat vehicle is static. It serves as a platform for further development. The designers of the T-28 understood that existing configurations would eventually require refinement to meet evolving military demands and leverage new technologies. Consequently, the history of the T-28 is not that of a single, unchanging design, but rather a family of vehicles that evolved over several years. There were 4 main production variants: the models of 1933, 1934, 1938, and 1940. Each introduced changes, including upgraded armament components, improved optics, transmission refinements, and modifications to assemblies that had previously caused maintenance difficulties. The year 1937 was marked by internal refinement. Design Bureau No. 2 at the Kirov plant, as the Krasny Putilovets factory had been renamed, recalculated various assemblies and updated the manufacturing blueprints. These changes were internal rather than cosmetic, focusing on reliability, service life, and operational handling. By 1938, these efforts resulted in stabilized production levels alongside improved build quality. Alongside planned modernization, other experimental work was conducted. In the autumn of 1935, Design Bureau No. 2 initiated work on a project officially designated the T-28 high-speed machine. The objective was to enhance the vehicle's speed and maneuverability rather than its armor or armament. This was achieved by redesigning the final drives in the gearbox. The lead engineer for this project was Efimov, the deputy head of Design Bureau No. 2. The initial trials of this new variant, designated the T-28A, took place on September 11, 1935. The performance metrics achieved during these trials remain notable today. The tank reached a speed of 55.8 kilometers per hour. This was achieved by a combat vehicle weighing approximately 28 tons, complete with 3 turrets, a 6-man crew, armor, and a full ammunition load. Reaching nearly 60 kilometers per hour represented a high speed for an armored vehicle of that weight class during the period. Following further refinements in the spring of 1936, an official commission chaired by Colonel Lizyukov, commander of the 6th Heavy Tank Brigade, conducted evaluations of the vehicle, which carried the factory serial number S910 and the unofficial moniker Stalin. The commission's findings were clear. The high-speed T-28A was declared fit for military service. Third gear, which allowed a speed of 46 kilometers per hour at 1,450 revolutions per minute, was recommended as the standard operating speed for cross-country movement. Fourth gear, enabling 55.8 kilometers per hour at the same engine speed, was designated for use on roads and well-maintained unpaved surfaces. This maximum speed was sustainable, allowing the vehicle to maintain high rates of travel without immediate risk of overheating or mechanical failure. The final production variant, the Model 1940 with its conical main turret, represents another key development. The use of a conical design was based on ballistic geometry. Shells striking an angled surface at an acute angle are more likely to ricochet or lose kinetic energy compared to those hitting vertical surfaces. Conical and sloped turrets became a prominent trend in tank design in the late 1930s for this reason. However, T-28 tanks with conical turrets remained very rare, with only 13 units produced out of nearly 600, representing less than 3% of the total output. These 13 tanks stood out as specialized units within the broader mass production run. September 1939. Conflict had begun in Europe. On September 1st, German forces crossed the Polish border. 16 days later, on September 17th, Soviet forces entered western Ukraine and western Belarusia in an operation designated the Liberation Campaign. This operation marked the first combat deployment of the T-28, moving beyond testing grounds and exercises into active service. Approximately 200 T-28 tanks were deployed with the Ukrainian and Belarusian fronts. This represented nearly a third of all T-28s produced up to that point. They were assigned to Mechanized Corps, tasked with securing rapid advances into the territory. However, significant combat engagements were limited. The Polish military was primarily concentrated in the west, resisting the German advance. The eastern regions contained only scattered garrisons, border guards, and units unable to organize sustained resistance. While minor skirmishes occurred, there were no major armored battles. Consequently, this deployment did not serve as a comprehensive test of the T-28's combat capabilities. Instead, it served as an operational durability trial. Nearly 200 vehicles covered hundreds of kilometers over varied terrain, including paved roads, dirt tracks, plains, and hills. This march demonstrated the reliability of the T-28's suspension and running gear under sustained use. The suspension handled the operational loads, track failures remained within normal limits, and the engines did not overheat during long marches. The transmission performed predictably, and drivers grew accustomed to handling the large vehicle. This was a practical, though undramatic, confirmation of the design's mechanical soundness. In military operations, mechanical reliability is as critical as firepower. A vehicle that breaks down on the march cannot contribute to combat operations, and high maintenance demands drain logistical resources. During the campaign, the T-28 proved capable of covering the required distances reliably. However, observers noted that the conditions had been favorable. The lack of organized opposition meant the tanks had not faced anti-tank artillery fire or coordinated defensive measures. The operation resembled a rapid road march rather than active combat. The primary combat test lay ahead. It occurred only weeks later, when the T-28 was deployed against prepared defensive positions supported by artillery and determined resistance. This was the Winter War on the Finnish border, facing a defensive line that Soviet planning had initially underestimated. On November 30, 1939, Soviet forces crossed into Finland. Planning estimates had anticipated a brief campaign of 2 to 3 weeks, expecting minimal resistance. The reality proved different. The Finnish forces withdrew to prepared, deep defensive networks. What had been assessed as minor obstacles was actually an echelon system of anti-tank ditches, granite boulder obstacles, timber and earth bunkers, minefields, and pre-registered artillery zones. Initial attempts to break through these defenses failed. The T-28s were then committed to the assault. In the absence of other heavy armored vehicles in sufficient numbers, the T-28 was tasked with supporting infantry assaults. The heavy T-35 tanks were few in number and carried operational limitations, leaving the T-28s to bear the primary burden of breaching fortifications. This task aligned with the vehicle's design doctrine, advancing with infantry, suppressing bunkers with its 76mm gun, covering the advance with machine gun fire, and clearing wire entanglements. While aligned with theory, the practical conditions of the Karelian Isthmus introduced unforeseen difficulties. First, the terrain was highly restrictive. The winter environment of the Karelian Isthmus featured dense forests that limited off-road maneuver, frozen marshes with unpredictable ice strength, and narrow forest tracks where vehicles could not easily bypass obstacles. These conditions restricted the tactical employment of the tanks. Second, the Finnish army was equipped with Swedish-designed 37mm Bofors anti-tank guns. These light, highly maneuverable guns fired high-velocity projectiles capable of penetrating the T-28's armor. This revealed a key vulnerability. The 30mm frontal armor, sufficient against small arms and shell splinters, was vulnerable to 37mm armor-piercing rounds fired from standard combat ranges. Crews were aware of these risks as they encountered Finnish defensive fire, but they continued to support the infantry advances according to operational orders. Material losses were notable. In addition to combat damage, vehicles suffered from the rough terrain and extreme cold, which dropped to -40 degrees Celsius. Operating machinery in such temperatures required specialized lubricants and careful maintenance, which was difficult to maintain under field conditions. The Winter War ended on March 12, 1940, with a peace treaty. While the Soviet Union achieved its territorial objectives, it did so at a significant cost. For the T-28, the campaign served as a critical test of its design. The tank performed its designed role, but the rapid improvement in the accuracy and availability of anti-tank weaponry meant its original 1930s armor specification was no longer sufficient. This reality was already recognized by design bureaus. Even as the fighting on the Karelian Isthmus continued, development was underway on next-generation armored vehicles. On June 22, 1941, the invasion of the Soviet Union began, changing the entire strategic situation. The offensive spanned a vast front from the Baltic Sea to the Carpathian Mountains. Soviet units, many not yet in defensive positions, faced immediate pressure. In this opening phase, the remaining T-28s were committed to the defensive lines. By the summer of 1941, the T-28 was no longer modern. Production had ceased in 1940. Many of the active tanks had seen service in Poland or Finland, showing signs of repair and field modifications. Some were fitted with applique armor screens, while others were not, and spare parts were in short supply, leading to varied levels of mechanical readiness across the fleet. Despite these difficulties, they went into action. A specific example is the 9th Tank Regiment of the 5th Tank Division, stationed in the Baltic Special Military District, which was among the first to engage the advancing German forces. The regiment's crews established defensive positions along the eastern bank of the Neman River, using the natural obstacle to monitor crossings and delay the opponent's advance. For 2 days, they held their positions. The T-28 crews defended the river line, using direct fire to disrupt crossing attempts and launching counterattacks against units that managed to reach the eastern bank, holding the position against numerically superior forces. This engagement is documented in the military reports from that sector. This defensive success was aided by the tank's remaining strengths. The 76mm gun of the T-28 remained effective in 1941. The light Panzer I and Panzer II tanks, which formed a notable portion of the German armored forces at the start of the campaign, carried armor ranging from 13 to 30 millimeters. This armor could be penetrated by the 76mm Soviet shell at standard engagement ranges. Even the more heavily protected Panzer III and early Panzer IV models did not possess a decisive advantage over the T-28 in direct gun duels. Although obsolete by 1941 standards, the T-28 remained a capable platform when properly deployed. The primary difficulties lay elsewhere. Fuel and ammunition supplies were rapidly depleted due to logistics breakdowns, and spare parts were almost entirely unavailable. Communication between units was inconsistent. Consequently, many T-28s that survived combat were ultimately abandoned during retreats due to mechanical failures, lack of fuel, or the inability to evacuate and repair them. Military reports from this period explicitly note that a significant portion of the losses resulted from logistical failures, fuel and ammunition shortages, mechanical wear, and the absence of spare parts, rather than direct enemy fire. This indicates that improved supply lines and operational coordination could have preserved many of these vehicles. Nevertheless, the crews operated under the conditions they faced, taking damaged vehicles into action, coping with limited ammunition, and defending positions without expectation of reinforcement. The history of the T-28 in 1941 reflects the efforts of these crews to utilize their available equipment effectively under difficult circumstances, as recorded in official accounts. In 1940, production of the T-28 was discontinued. This was not due to mechanical failure or crew dissatisfaction, but because the strategic landscape had shifted, rendering the multi-turreted concept obsolete. To understand this transition, one must examine the development programs running alongside the Winter War. By 1939, as the T-28's armor was being tested by 37mm guns in Finland, Leningrad factories were already constructing prototypes of two new heavy tank designs, the SMK, named after Sergei Kirov, and the KV, named after Klement Vorshilov. Both were heavy designs featuring thicker armor. They underwent operational testing in the active combat zone of the Karelian Isthmus. The KV demonstrated superior protection, resisting the 37mm anti-tank fire that posed a threat to the T-28, which pointed the way forward for Soviet tank design. However, the transition involved more than just armor thickness. The early stages of the Second World War in Western Europe provided military theorists with new data. The German employment of armored forces emphasized high mobility, concentration of force, rapid breakthroughs, and deep penetration, rather than sustained engagement with static fortifications. This represented a shift in armored doctrine. In this operational context, a multi-turreted medium tank with 3 turrets and a 6-man crew presented clear drawbacks. While multiple turrets allowed engagement in different directions, they also complicated internal coordination, increased maintenance requirements, added structural vulnerabilities, and raised manufacturing complexity. Experience showed that a single, well-designed turret with a capable main gun and a coordinated crew of 4 to 5 members was more effective than a multi-turreted arrangement with its complex command requirements. This led to the decline of the multi-turreted concept. This shift occurred globally. Great Britain retired its multi-turreted designs, Germany did not proceed past prototypes, and France and the United States arrived at similar conclusions. The concept was a product of its era that had reached the limits of its utility under modern combat conditions. The T-28 was succeeded by 2 designs, the T-34 medium tank and the KV-1 heavy tank. Both featured single turrets, sloped armor for improved ballistic protection, and simplified manufacturing requirements despite their superior performance characteristics. The T-34 became one of the most widely produced tanks in history, with tens of thousands manufactured, whereas approximately 600 T-28s were built over its 8-year production run. However, a key aspect of this transition is worth noting. The T-34 was the product of a decade of development and operational feedback. The engineers who designed the T-28 learned from its service, identifying structural weaknesses, layout issues, and mechanical sensitivities under field conditions. This practical experience was directly integrated into the design of subsequent vehicles. The T-28 was not a developmental dead end, but a necessary developmental step. In the history of military technology, early designs often provide the foundation for later, more successful systems by training engineers, manufacturers, and crews in the requirements of modern armored warfare. With 600 units built, 3 conflicts contested, and a generation of designers, mechanics, commanders, and drivers trained, the T-28 played a foundational role in the development of Soviet armored capabilities. This remains the legacy of the T-28,